Mm.
So, welcome everyone to the webinar. Should we wait for a minute or two for people to join in? I think people are still joining in. Uh, I think maybe we can start. So this is an RFCs we love, and this is uh, as part of IIESoc. We organize these webinars called RFCs we love. We organize also an annual pre-IETF event called Connections, which has been held at Kolkata, in Bangalore, and remotely as well in some years. We have had very gracious support from INTC, and in coordination with INTC, we have conducted several webinars, such as IPv6 webinars, where we've talked about various beginner understanding of IPv6 to various special topics. And most recently, as well as IoT webinars, as well as most recently, you may have attended the Content Distribution Network webinar that happened last week from INTC. Uh, so we welcome you all, especially those who have joined for the first time, to become a member of INTC and IIESoc. Our members work closely with the IETF, and please feel free to join the mailing list, the WhatsApp group, the LinkedIn to stay connected and know more about our events. In today's webinar, please use the Q&A, Zoom Q&A, or raise a hand if you have any questions, and feel free to use the chat for any other discussion. So today's webinar, RFCs We Love, is about networking, telemetry with gNMI and gRPC. Now, some people might wonder why these were, that may wonder that these were introduced to the IETF as internet drafts, but they never progressed to become RFCs or, standards. So how are we talking about them here? We are talking about them here in the RFCs we love because we are an open space to discuss things that are being used by our standards community. And a lot of companies today use AI. And people who use AI and use these LLMs, they use these SDKs, which are also are built on top of gRPC and protobuf. And so these kind of things are unavoidable. So please note and know that there are IETF protocols and extensions that are also applicable, right? With that, let's welcome our speaker, Sudhin Jacob, who will be speaking on this topic of next generation network observability from CLI scraping to AI driven telemetry. Now, Sudhin is an IIESoc member, and in his long career, he's an NLP AI specialist and a network engineer with a long experience across Juniper, Google, BSNL, etc. So, with that, I welcome Sudhi, and I hope that I can stop sharing and he can start his talk.
Thanks, Priyanka. Can you hear me?
Yes.
Thank you. Let me share my screen. Give me a moment, please.
Yeah, it would be good if you could also turn on your video.
Yeah, sure. I think they have a bandwidth issue. So I'll start for a moment the video, and I will address the audience. Then I'll turn off the. Hi everyone. My name is Sudhin. I have almost. I'll explain about myself. I have a slide for it. So I'm in the industry for almost 23 years. So currently with Google, I'm working as a test engineer. So I work in the telemetry sessions. So I welcome all. Thanks for joining, and it's good morning, uh, good evening, everyone. So let me start my presentation. Are you able to see my screen?
Yes, yes, we're able to see you.
Perfect, perfect. So my presentation is about, I mean, it's a journey of a network operation engineer. An engineer work in the NOC, or is an engineer who's as working as SRE, or in the operation area. For his journey from a traditional systems, a story of network engineer from a traditional systems to the new generations of telemetry, and how I'll walk you through how this solves his problem, and how it will increases his efficiency, and thereby solving most of the problems and increases the network uptime. So in that, so let me start my presentation. So disclaimer, I speak on behalf of myself. I don't, speak for any organization or any my employer or any other organization. I speak on my capacity. I don't represent anybody, and this is of what all I speak. It's on what all is on myself. So it's a little bit about me. I'm a double CCI in a routing and switching and service provider, emeritus, and I have a master's in AI ML. I specialize, as Priyanka mentioned, I specialize in natural language processing. So working on automating that and using the NLP techniques to solve the network problems. And mostly 23 plus years of experience in the network industry. Basically, I work on service provider. Then I was working with vendors and the cloud providers in the area of service provider, as well as in the data center. I have 7 US and Europe patents, and a small IETF draft, which is adopted by the IETF community for the EVPN benchmarking. So that's about myself. So today, the agenda is about the problem, as I said in the start, like the problem faced by the network engineers, the legacy systems who were working on that, and what were the legacy tools which are using, and the rise of model driven telemetry and the streaming, how the AI is coming into the a lot of AI buzzwords, and also how the AI is helping us, and what are the futures, and what all the roadmaps I heard, and what all the innovation as a network engineers we can do. I mean, what all the innovations we can do, and there are a lot of things which is ahead, which I'll touch upon, and in the final, we'll have a Q&A sessions. So the initially the problem with before the model driven telemetry, the people working in the people who have worked in the NOC or in the SREs, they know the pain points. It's like it's knowing the network visibility. They have like if you manage 100 or 200 devices, still okay, but it's not okay, but still somehow you can manage. But you are several thousands of devices, and what is happening, there is no way to get a full picture about it and to know proactively what is happening. So traditionally, we were looking into like either a custom made ticketing systems. It will throw you a bunch of errors, sometimes false, I mean bunch of tickets, and sometimes are false alarms. Sometimes the alarm, it generates alarm which is already rectified. So this kind of issues were there, even using the SNMP, and it has its own issues. And most of the SNMPs work on the polling, and it gives you it's a bunch of data points, but it doesn't give you the context what exactly it is happening. And so the network engineers have to work the triaging for each vendor, for each vendor, like say XYZ vendors, they have their own operating systems, and they have multiple operating systems, multiple systems. It's very difficult to and one person is like a CLI jockey used to do either one specialize in one X vendor and another one in Y vendor. So it is knowledge, there's a knowledge gap, and it's very difficult for one to go in across the multiple vendors, and all the providers as well as enterprise systems have a multi-vendor system. So it was a bit of painful. And another area which was to solve some of the context which was missing was a CLI scraping, which any program, Python or any programming language use uh, versatile, I mean the regular expressions you use. And but the problem comes is another version, if the current version it looks okay, now another version they change the CLI or change the output, then again that's a bug, and you have to constantly be on the top of that for this automation and all. So these are all the core issues which were faced by the network engineer, operations engineer, or the NOC engineers in earlier times, in the during the 2000 to 2010, and even some of the traditional systems they face it. So then in the late, I mean, it's in the early 2000, sorry, from 2010 to 2014, 15 time frame, the things starts developing. Actually, the cloud got tractions, and traditional data center got changed, and more and more services, products and services which the cloud providers which is offering to the customers, and customer base starts building up, more and more network elements starts adding into the system. So this SNMP could not is was not that scalable, and you have a delay in getting the data, and you need data points in a subsequent changes which is happening, and the burst of data which is going, so which the traditional systems were lacking. And different vendors speak different languages. I mean, it's very difficult to have a uniform systems so that engineer can make a sense out of it what is happening. So that is where a model driven telemetry approach. So earlier it was for unstructured kind of thing. So then the people work in IETF then modeled the young models were at another next generation. That structure, okay, you have to model the data, you need to define some structures to it, and then different models like different, the young got adopted by all the vendors. So and each one defined its own models in, and their own private extensions and all. So model based telemetry, and different people use netconf, resconf and all with this. And then OpenConfig community starts with gRPC gNMI. Slowly all most of the people starts working towards it. I'll come to that. And why the model driven telemetry got this much of traction is like, it is one is a structured, the young based one, and it's not a pull based system, it's a push based, even though it is pulling is there, and I'll come to that, but most of it is a push based systems, and hierarchical, and you get a vendor neutral, I mean all speak same thing, so you can gain intelligence out of it. And one of the implementation is a protobuf, so which you reduce a lot of overheads, and thereby reducing the bandwidth. You won't have that much of chatter like no other way of implementing this model driven. And it is easy to feed to a AI ingestion. It's a structured, so you cleaning and processing, pre-processing overheads are reduced over here. And SNMP is like, you can say analogy like a reporter is asking, hey, every 30 seconds, it's what is happening. Model driven telemetry is, yeah, you have everything, dashboard, everything is there. And it's unstructured. I mean, it solves this kind of unstructured, stale, fragmented kind of a problem. And with real-time monitoring systems and all, this model driven telemetry has the potential to provide, and it is well suited for cloud based systems. So as I said, in model based telemetry, different way of implementing it. And I mean, you use netconf, and then resconf and all. gRPC also got tractions, and when the OpenConfig starts working on it, so they agree upon gRPC. gRPC was pretty much useful. I mean, it was one of the most used in cloud, as in microservices and all. So gRPC was is a versatile in one sense. It's use a protobuf and it's built on HTTP2. And another benefit is like it is not tied up into one particular language. Say for example, you can develop your collector in Go and your server in Python, and you can have a choice of language. So so you are not tied up, okay, both should have same kind of a language. So independent development is possible. So I mean, it is vendor neutral, and it has security and scalable facility. So gRPC got tractions, and so gRPC thought, okay, let's use gRPC for that. And in the gRPC itself, it is broadly divided into four. It is one is unary RPC, server streaming RPC, client streaming RPC, and bidirectional streaming RPC. So this four is a bread and butter for the gRPC. So this four can be, I mean, used for various services. I mean, you can use unary RPCs if there is you want a little bit of data. You can send, hey, client can send a request and server responds to it. And if you have a service, if you have a client just requesting a server, and server, you need a server to respond a bunch of streaming data, it's possible. Even the vice versa, so a client can stream a bunch of a data and server responds to it. Bidirectional streaming is like an independent two independent highways, so both can talk each other, and if one want to stop, it's fine. You can have independent highways, like a highway, the two sides traffic which is going on, which won't interfere with each other. So you can say it's like a unary, it's analogy. You can say like it's a unary RPC is like you ask one question, you get an answer. Server, I mean, I ask one for an update, server gives you a bunch of updates, and client start giving you a bunch of information, and server process it and gives you the response. And bidirectional is both, it's kind of an example, you can say chat operation, both sides of operating independently. It's just an analogy. So the building block, as I said, right, it's a vendor agnostic. I mean, so it's a open. I mean, the standards, like you can develop the client and I mean the server in different languages. But how this has become versatile is like you reduce the overhead. How there is, it is by protobuf encoding. So it is you have to tell, this is an example of a protobuf. It's a proto 3. You define a proto file. You tell that, okay, I'm going to send, I'm using this kind of services. I use maybe a unary RPCs or a streaming RPCs, and in my messages I'll be putting this much of the data. So both parties knows that, okay, okay, I'm sending this much of a payload to my other party, and other party knows that, okay, in position 1 I have this particular payload, and position 2 I have this kind of a payload. So they know. You don't need to send it like a JSON. You have to send all this extra overhead over that. So you know it, and it's binary encoding, so it compresses that. So your bandwidth is also unnecessary. It won't waste your bandwidth. It still uses it, but it's compared to other ways, it is compressed, and it can have, it can use compressed way, and it is a scalable way. When you do in a cloud scale, it is very much scalable. So SNMP, it's like, you can say, kind of a unary kind of a thing. You request response. gNMI and gRPC, gNMI, which I'll come later, and gRPCs, which I already explained. So it enables for gRPCs, which can use for a real-time, low latency and scalable telemetry options. And you can, which I'll explain, that load of data points you can collect, and which is from several hundred thousands of devices, and it's very scalable and real time. So you can get real analytics and predictive telemetry based on that. So then, as I said earlier, in the model-driven telemetry, a group of people, they said like, okay, we have gRPCs. Some went with a proprietary way of vendors implemented their own way of doing it, and the OpenConfig, the community came together and I said like an IETF, this OpenConfig says like, okay, we have these pain points and we are not getting all the data points, and we want a sub-second data, and it's a scalable way of doing it, and it should be a vendor agnostic. Like, it's we want everything. So we give a structured way of YANG models. So all of should support. It's like everybody, yeah, it's in high level in the bird's eye, it is looks good, but in the real way, real implementation, there are a lot of pain points are still there. It's fixing one by one. So almost all the vendors agreed, okay, let's do it. And just slowly start adding to it. Like initially it was very less support was there. Slowly now it is adding to it, protocol starts adding to it, then the interface details, now the AFT, all the data it's getting to it. So the gNMI, it is in the OpenConfig umbrella, you have a gNMI. It is gRPC based network management interface. Basically, it's a protocol for network telemetry and configuration of that. It's a standardized way of doing it rather than CLI based. You know, one vendor, X vendor, have one set of CLI and another vendor, so you don't need to worry about that. You have a structured way of doing it. So this solves that problem. gNMI solves that. So it under the hood, it uses the gRPC, and under the hood gRPC uses the TCP and HTTP2 on that. So which will I mean, it's an efficient way of and secure way of communicating with the both ends. So as I said, so these are all the benefits of gNMI using the gRPCs. I mean, the structured, it's a reliable transport compared to UDP and SNMP, and encoding, which I said is a protobuf encoding. It is, I mean, language agnostic. I mean, language independent. Like you have the choice what all language you can develop in the both side. All the thing you need to agree upon the protofiles and securities and another extensions. So this is a main benefit which over the netconf, which is you, I mean, the gNMI gRPC can have the facility that you don't need to send all the data at all the time. So you, if the particular router or a switch or whatever the network element is, like if once you send the data the first time and second time, if there is any change, you can inform them, hey, there is a change happened in the interface went down, or there's a route change which has happened, so forwarding table change happened, so you can just inform that. So that is way this is much better compared to other way, other implementation. And moreover, so this reduces unnecessary chatting or over the network if you are using in band or out of the band way of managing your network. So it is native streaming is also uh, supported. And now I think everyone is moving towards gNMI gRPC based system from a traditional native streaming. So the gNMI basically has got four modes of operation. So they have defined four RPCs. They said like get, set, capabilities, and subscribe. So get under the hood, which uses the unary RPCs, which I said, right? There are four types of gRPC. So get, which uses the unary RPCs, and set and capabilities also uses the unary RPC. So you just request, get the response, done. But the subscriber is where, which is it's a real I mean change in the compared to all other system. Is like you have lot of features. It's a bidirectional streaming RPCs, a lot of features is get added to that. So this is an example wherein like capabilities, earlier it was very difficult to understand what is supported. Now this is the gNMI, the capabilities. I request for the capabilities, the collector can and I'll come to know, okay, these elements have this much of features. Based on that, I can change my subscriptions. So get is you want a small snapshots, and set is wherein you should to configure, modify, delete, or add the configuration, and subscribe is where you stream the data. So this is a typical example. You know, it is defining in the proto service. These are all the RPCs which is defined in. This is a snapshot from the gNMI.proto file. So these are all the RPCs, and there are different messages are there. It's a long file. I'll provide the link at the end of my presentation. So here, which I've already explained, get, set, and capabilities. Now it's the important part, as I said, right? The subscribe, I've got a lot of options. Like that is where the main attraction of the subscribe bidirectional RPCs which is used. Subscribe, you can use it for once, polling, streaming. The streaming itself is subdivided into two: on change mode and sampling. And then you have the target defined. Most of us, we don't use it. Mostly we use the polling and the streaming. There are certain cases you want at just get the data, the entire data, so you can use the once. The polling means sometimes the polling is CPU intensive. Sometimes the vendor does not support the streaming because huge amount of data, it okay, from the forwarding as well as the routing and another the management plane, it has to give it to the telemetry daemon, and it has to subscribe. Most of the vendor, so they said, okay, we will give you the polling. So polling is a subset of that. So but it's again, it's a client driven, it's not a push, it's again the client, it's a pull kind of a method. But the problem here, it is a CPU intensive, not it's not heavy. You cannot depend fully on the polling, and it is a CPU intensive process. So but till the streaming is supported, it is kind of a an arrangement. The subscribe, I mean, once and poll, I mean, if it is used accordingly the needs of the user. And here it's streaming, it's a versatile of streaming is where the sample mode and the on change mode. So in the sampling mode, I mean, if the particular vendor does not support the full taking of the entire data to the collector, you can tell that even the sample is also a push based system. So you can say, okay, the vendor can say, okay, this device can give you this much of data. And suppose you want the time series of data to plot certain usage of the memory or anything, so sampling is useful. So you have I mean, the timestamp, and you get a sampling interval, so you get all the data. And if you need for the analytics or the AI ingestion, you can use that. And streaming is mostly used when you have the fib table, the entire internet scale. You can't send the entire internet scale or every interval. So the on change, what are the route change, what is the next stop change which is happened, is the interface down, or what is happening. So they changed information which will be sending to the collector. So it's a typical use case. I'm just using a path. So getting an AFT is a forwarding table for IPv4. It's an on change. I'm telling it, and the encoding is JSON ATF, and the server responds that information as a notification with the next stop, and in the container with the next stop interfaces and all those information. This is an example of a subscribe response for a streaming mode on change. So now, as I said, right, OpenConfig umbrella is a gNMI is one, and gNMI is where the operation-based systems, like for reboots, installs, and all those things. And gRPC is where when you have a controller and you can program your forwarding table, and you can push the data to that, and you can program the forwarding table. So it's suitable for I mean, suitable for controller-based systems. Like it's you get the information and you feel that okay, certain traffic has to be engineered into that particular one particular path. Is a less traffic, so you can engineer that. So basically, this is used for SDN based controller based systems, not in a distributed kind of a system where you have each router have independent entities and talking protocol. Mostly suitable wherein you have a SDN controller which pushes, you have the visibility of the network, and you want to engineer the traffic into one particular way, and you want to push certain traffic or a certain I mean the traffic colors to be pushed in certain way. This is very useful, and it's pretty easy automated. And the analytics, AI can using giving to the AI engine and its feed, and based on that it can take decision. Again, it's with a pinch of salt. Okay, and sometimes it can go wrong, then creates a problem. So this is all the different areas of the development. This is a typical example of a gRPC, how it is modifying or deleting a particular route from the fib table. So GNI is basically used, for the reboot operation, file transfer, installations, and all those things. Because sometimes you need to, in a maintenance window, you need to reboot the operation. Reboot operations is done, or CTP, or I mean the configuration CTP, all those things. The GNI can help. So now come to the AI plus the gNMI gRPC telemetry. So what is a, as I said earlier, right? So this is a structured data. So it is the amount of time required to pre-process this and feeding to the ingestion to the AI engine, either as a time series or a classifiers or a NLP. I mean, where in the rule-based systems or anything. So it's easy. Yeah, I mean, it's not that easy, but it's compared to other one, the cleaning and all things, the work is much reduced. So basically the main benefit is that you have the timestamp data which is there when the notification comes. You have the timestamps, and it's a structured, and it's a bidirectional streaming, so you get all the data, and if it's a change happens, that change data is there. And if you want the sample is also there. So accordingly your business logic, you can select that. That is the versatility of this. You can either go for sampling, polling, on change, or sampling, polling, or on change mode. We can go for it. So basically the AI which is wherein which we can use is like anomaly detection. Like you get the data that the particular leaf, you subscribe to that and you get a particular leaf, and you feed into that engine, and you can see if there is any leak which is happening, or if it's a link is a degradation which is happening, and you are the errors are there. Like you can proactively go for a maintenance or inform, I mean, if or the hardware, you see that the alarms are coming up, the temperature or the alarms are for the line cards, you can proactively, the engine can go for RMA or kind of a things. And predictive maintenance, you can use a neural network, or I mean like it depends on the LSTM or any neural network to have a see, or if any time series, you can see based on that what is I mean what will be the next interview. Is it going to a leak or it's going to a failure based on the errors? Traffic optimization is also possible by analyzing the spike or the anomaly, and you can re-engineering the route. Again, human intervention is needed. I mean, man in the loop is very much needed, but the slightest mistake is very catastrophic in the network, but it solves many of the problems of the network engineers. So it is if you feel that once I feel it's my suggestion is like always human in the loop in this kind of a high reliability systems. Always a decision making it is there, unless and until it is to be trained, but still monitoring is required. That's my take, and based on my experience which I have there, and people can disagree with me. So the capacity planning, so you feel that this links are overutilized, you can plan for that. The automated like AI agents can do triaging work. Instead of earlier engineers used to get an SNMP traps and used to go and do all those things, that can be automated, and you don't need unless all this triaging can be AI agents can be done. They can do multiple agents can be deployed in the collector in tandem with the collector, and it can solve many of your problems, and the agents can do it. And finally the escalation engineers can take a call on that. And it is again, it is very useful for the security. I mean, you can see the anomaly in the traffic patterns and all. Based on that, it it can inform the engineers. So I hereby, towards the end of my presentation, so these are all the reference which I place it, and it's I mean, the context data without a context is a problem. So it's a Hannah Fry in her book Hello World, it's mentioned that if you overly depending on the AI systems, then you will be facing problems. So she has mentioned a lot of classical problems, and you fully dependent on that without the context. The Annie Jacobson in the first platoon, so one of the company like which I would like to explain is like uh, they predicted, okay, go for a strike. but the human which was tailing that particular entity knows that that was a false alarm. So he prevented that catastrophic things. So you cannot every time depend on that. These are the systems you built, and you should know what exactly you are doing it, and you should know what you don't know, and you should know what you know it, and you should be aware of what you have it. And about apart from the hype, because I've been studying this, so I know what is hype and what is a kind of a reality. So it is mixed of that. AI can use as a tool, of course, and seasoned people should be there to safeguard that. Guardrails should be there. That's my take on that, because otherwise it can create havocs. And these are the systems which can reduce all the mundane work which engineers can do. But at the same time, due diligence has to be there, and you should know what is the context you are building the model. It's just like randomly picking up something and doing that. It doesn't make any sense at all. So you should be very aware about what is doing. There's the four books which I like it. Is all mentioned about that in the hindsight, or like in the blind spot, people used to rely on the system which are, and because arrogance or pride or whatever ego it is, like say it is. But it's not like that. But you need a little bit of understanding of the system, as well as what is happening. So the context is very important. So here ends my presentation. uh, I thank you everyone for listening for almost 40 minutes. I take the opportunity to thank you and IIESoc members for giving me the opportunity for the presentation. I think we can open for the Priyanka. You can open for the discussion Q&A.
Yes, thank you so much, Sudhin. That was a very exciting talk. Maybe the first question, maybe Vicky can ask. Vicky Risk.
Sure. Sunil, thanks for the presentation. I am familiar with using gNMI for monitoring routers and network infrastructure equipment. I am considering whether or not it would be appropriate for network applications, such as like DNS servers, DHCP servers, important network applications. So I guess and there are YANG models for configuring these, but those YANG models are not really appropriate for monitoring. They're more, they're just addressing configuration. So I guess maybe I saw an example in one of your slides of monitoring for memory issues on the network equipment you're looking at. So I guess maybe one specific question to ask, is there a model for, say, monitoring a generic Unix server? I'm just really trying to probe if there are existing standardized data models for monitoring applications running under Unix.
Uh, Vicky, I don't know about the Unix system in the routers. Some of the vendors have implemented for memories and the system-based YANG models, so they are using it. Some are using it, not full-fledged. But the Unix system, I don't know, because in the router it is there. Some of the
Right,
vendors are
right.
supporting it.
Right.
I
It would
don't know.
be fairly different. So most of the the kind of applications I'm thinking about, there is a lot of usage data, but most people are exporting that to a system like Prometheus and um, analyzing that in something like Grafana, and it's quite intensive on the application to provide all that information. So they're not going to provide it two different ways. Well, I guess if what you're saying is you don't see this being used today for monitoring, say, servers, then perhaps this is not the right path for us.
Vicky, you
We have YANG model support already, but as I said, I think those YANG models which are for configuration are not really aimed at monitoring.
Vicky, you can check the OpenConfig model. If that particular OpenConfig YANG model is there, then particular, like say for example, anyway, you need both parties. Like you have the client or the collector, and you have the server to communicate. So it depends on that particular server vendor supports that particular model or not. If that is there, then I think, and purely on logical perspective, I may be wrong. You can implement. Like we have certain use cases where the vendor provides that, so we collect the data and we process accordingly. So we have use cases. So if the model is supported by your vendor, that server vendor, then I think it's a matter of the collector. You write the program in any, I mean, any language, Python or Go, and you can collect the data and you can do it. Yes, you are correct.
Right. We are the vendor. I'm trying to decide whether or not we should bother supporting this.
Mhm.
And I mean, obviously there are many YANG models that are not part of OpenConfig. I'm thinking about, the IETF standard YANG models.
Okay. Thank you.
Okay.
Okay.
I think I've got my answer. Thanks.
Thanks. Thanks, Vicky. Maybe Andre can go next.
Thank you. I used to work a little bit in network management. I worked on AT&T's implementation of HP OpenView a long, long time ago. As I was listening to your talk, I was wondering about the overhead incurred by all the streaming, the bandwidth costs, and so on. But I was also concerned if this monitoring system and configuration system is mission critical, does it have the ability to monitor itself and reconfigure itself, especially if a monitoring or a control channel goes down either physically or virtually? I'm thinking of what happens in the SNMP environment when an articulation point, a node that has a lot of traffic to going to many different places going through it, and it's on a unique path. What happens, you see a lot of stuff being down that isn't necessarily down, but the intermediate node is down. You don't have any way of knowing about it. How do you address this? Can your system reconfigure itself if a monitoring path goes down, for instance? And what kind of overhead is incurred at the monitoring station and at the source where the stream comes from?
Okay. So let's, Andre, thanks for the question. So here is the three parts. Let's break into that. What is the overhead? So say, for example, I can correlate with our systems like the routers and the collectors. So the router, the overhead will be very less. As I said, right, the encoding is in protobuf. You are not like the JSON. You don't have any overhead. So the information and it is compressed. The data is compressed. So you don't have that kind of chatter unless and until you are not streaming the entire internet scale routes to your system. Point number one. So either you are monitoring your anyway your BGP or BGP state or interface state or counters or anything. So your overhead will be less unless and until the fib, the entire fib you are exporting to your collector. That's point number one. Even that can be solved using on change mode. The one time you have the overhead, after that you will be the change will be the devices will be sending to that. So that by on change mode your problem can be solved. So that won't be, it's not that chatty. I mean, there won't be that much chatter in the network, so thereby reducing unwanted chatter. Point number one. And point number two is, can it auto correct it? It depends. I mean, it depends on your system. If you see that hey, if the link is gone, if the link is degrading, so you want routes to be programmed, you can use a if you have the collector you are using, as I said, is the gRPC, you can program the route to use in a different path. That is also possible with the gRPC. Again, it depends on the case to case. I'm telling you the logical flow of things. It is possible. So, and the third thing is the monitoring. Of course, gNMI gRPC is for the monitoring. So the collect, you give you the it gives the full context of the picture, what exactly is happening, and with connecting to the ingestion engines, it'll give you the prediction also. I mean, like it's a time series, like it is going to degrade or the traffic is going to spike. Based on that, you can capacity planning and all. It is possible. So I mean, there are use cases which we were using in different scenarios. So does that answer the question, Andre?
Yes, it does. If I may have a follow-up, I don't know how many other questions are in the queue. If you've got compression at the sender, that incurs a latency. Maybe it's very efficient. And similarly, if you've got compression at the receiving end, where you're going to be displaying the alarm messages or whatever, and dealing with the information and prescribing an intervention, that decompression incurs a latency as well. Are those latencies very long?
No, here, see, I have tested, and also the latency, it won't, because you get the sub-second information here on change mode. So the one benefit of here, it is you are not sending the offsets, I mean, or the metadata, or what you call as the JSON. You have the headers, so you know the information which is there. You get the notification, the protobuf decodes it, and you get the information, it is there. So that way, unless and until you are the TLS and all those, the overhead in the transport layer, that latency, and it depends on the directly proportional to your network latency from your network element to the collector. That, yes, if that pipe is chalked, if it's an in-band management, yes, Andre, I agree with you, there will be. Other than that, because you are removing all the payload, I mean the other header information there, and you know what exactly the server is sending and the collector is expecting that, and if there is any mismatch, there is an error already generating from the collector. So that way
Oh,
it is, and it's a TCP. If any loss of the packet, you can have a retransmissions, right? So again,
mhm.
it boils down to your depends on the link bandwidth and all. So how do you send your management traffic? You have sufficient, or it's how do you color the traffic? I've seen certain cases wherein it gets dropped because marked wrongly in the best effort queue, and it's get dropped. There are cases are there, so accordingly you need to take care of marking of the packet accordingly, it's so you can process.
Right. Thank you very much.
Thank you, Andre.
Thanks. That was quite exciting. Mike, would you like to go next?
Sure. First off, thanks for a really good presentation. You presented the information in a very discernible and exciting way. And you got me excited thinking about how to use some of this stuff. So I'm going to do an example. Let's say you have hundreds or thousands of RHEL servers, and you're using some of the traditional methods today that you described that aren't quite as good. CLI scraping, I think you called one, and SNMP, and logging is a big one that a lot of us use. But we want to try some of the things that you've described. What do we have to do there? Is there a RHEL package, or are there products we should install, or how do we get started in this, what you've outlined as a very exciting environment?
A good question, Michael. Let me explain. There's a two-step process. One is you are using the network element from any of the major vendors. I'm not naming it. It. The top three or top four all supports this. So I work with all the major vendors. Like what are the top four? I all supports this. So that problem is solved, and depends on that which image they are using. You are using not the latest, then not all are supported, and some vendor, one major vendor, they use their own streaming. So then honest lies with you, Michael, you have to convert that and provide the useful information. So they use a native streaming, gRPC native streaming, and the latest versions all supports gRPC gNMI. So there is the vendor should support the point number one. And point number two is everything is open source. You can just clone that repository, and you can develop a collector. You can develop a collector. Either there are different design. Either 1:1 you can do redundancy, you can do, or you can use a Kafka. So you can design a collector and ingest the entire the data into a Kafka. So that is a scalable way, cloud scale. You can do it. That is one way of doing it. So then the beauty of that, you use Kafka is like you stream into that, and the data remains in the Kafka, and your ingestion engines can take it, or your anomaly detector can take it. So instead of collector doing everything, that is one way of, you can design it a scalable way you can do it. Another way is 1:1. So you have lots of server, you have lot of money, you can have, because you depends on the amount of telemetry you collect. There huge amount of data is coming second, I mean minute base. So you should have sufficient money or budget for that. You can have a dedicated servers for that, that way also. So it depends. Only the cost of involvement is you have to have a server and then clone the repository, and either Golang or uh, Python or whatever it's your preferred language, you can do it. So because anyway your the support is there from major vendors, and you have the flexibility to any language, because we use Go, people use, some people use Python, and it's up to you. Does that answer the question, Michael?
Yeah, I think it does. And a follow-up question would be, so if we get into some of the even more exciting things, which is not only collecting and processing the information, but leveraging it and using it to maybe make some dynamic changes and fix issues that we're currently experiencing. If we
That
get to that, if we
mhm,
get to that level, and I know that's kind of a step two or a subsequent phase,
mhm.
but does that, from installations that have done that already, are they running into issues with change control systems or change control policies?
Okay,
It- it-
Michael. hmm So the question is like, I mean, self-healing kind of thing. That's a research which I'm working on it, like self-healing network. So this ingestion can, as I said, right, you feed into the Kafka, or that from there you can use agentic AI or a NLP-based system to do the triaging work and all. Again, if you make a change in an AI-based system, it take it with a pinch of salt. Okay, AI cannot solve everything as the hype. Excuse me. So always an expert or a man in the middle should take the decision. That's my take, like based on my experience. Many differ it. So this is purely my thought process based on my experience. Like always man should be there, the final decision maker, but the agentic AI can be used, because these are all the areas which I am working, I mean work on, I research on it. So with this information, because it's a structured data and it's very easy to you don't need much overhead in pre-processing the data and feeding into all these models. So it is a doable thing, and it depends on your business logic. You want, say for I'll quote a simple example. You want a link, it's a link is a degrading and unnecessary, you are losing the packet, so you want to shut down. There is a I mean the gNMI set command to I mean make that particular link shut if that error rate crosses the threshold. It's a simple thing. And but if it's a, say for example, if it's a major bank, then you need a change window. The business stakeholder has to approve it. If it is a trading floor, then you can't just do like that. It depends on business to business and case to case basis how the management structure for this particular changes. But as an engineering point of view, a designer perspective, it is possible, Michael.
okay, really good answer. And once again, a great presentation. Thank you very much.
Thank you.
Hi, so I think Boris can go next. He had a short question whether the gRIBI support is there on vendor's side, and he doesn't think it's really popular.
Yes, exactly. Very short question.
Boris, one of the couple of vendors supports it. They are using, glued to the SDN based system. I can't because tell the names of that. So
Oh.
it is possible, and you can do it. Or I mean, this supports that. To answer in a short answer, yes, certain vendors.
Thank you.
Um, then Henry had the question whether you could name some of the vendors or equipment that already support gNMI.
Okay, that's a tricky question, because as I said, right, I can't name the vendors, but the old, I mean the vendor which I work, I work majorly with Juniper. Juniper, I can say, and Cisco. also supports that. Arista supports it. So I can name that. In general, it's all there in the, I mean, the internet. You can search that. Arista also, they have a lot of pages there. Arista is the first vendor to support all those. It's there, in their Arista gNMI pages. It is there. Juniper supports. Earlier they were using native streaming. Now they are supporting it from the latest release onwards. And Cisco also supports that. It depends on the
So,
which image.
Sudhin, these are only in simulation environments, the gNMI, or in production as
No,
well?
that's all used in the production. This all used in all the. I'm talking from the production perspective, but I can't go into the details of it. As I said, right, I have certain restrictions. It's I'm talking. I'm working on the production environment. It's not simulation. It's all running in the production environment. So most of
Great.
the it's using in the cloud scale kind of a systems. It's running.
Great. So this has been a very exciting talk, and I want to thank the speaker very much. And as we all know, next week we have IETF 124, and hope to see you all over there. And there are remote fee waivers still available. And I hope everybody enjoyed the talk, and see you next time. Thank you.
Thank you. Bye.
Bye. I don't know. What's this?